All right, here's the second part of the pH calculation notes. Now, here are some more equations. Now, we've already seen that pH is negative log of the hydronium concentration. That is the definition of a P function. Just like you see an X, the letter X in math, that means to multiply. If you see an exclamation point, that means a factorial. And in math, if you see a P, lowercase, that means take the negative log of something. And we can have PKAs, PKBs, pH, POH. We can take the P function of anything. So we have negative log of hydronium, negative log of hydroxide. And the way logs work is that when you take the log of this value, like take a look at this equation, and you take the log of something, what you do is you add those exponents together. And so, if you take the negative log of this, pKw then becomes 14, because it's negative the exponent, which is 14, and it's going to be pH plus pOH. So pH plus pOH equals 14. Now, a lot of times we're going to be given pH, and we want to be able to go backwards. Well, what's the opposite function of P? It's antilog. And that's going to involve you either using the shift or second button, log, and then the negative of the pH. You can do the same thing with pOH. Okay? Now, it's really important that you're using your calculator correctly. Have a list of these equations ready to go. We're not ready for this one yet. And let's take a look at some examples. All right, if I have a hydronium concentration of 1 times 10 to the minus 7, I take the negative log of this value, 1 times 10 to the minus 3. I think I said 7, but I meant 3. It's going to give us a pH of 3. Well, what do we know about pH and pOH? They have to add up to 14. 14 minus 3 is 11. Okay. Take a look at letter B here. 1 times 10 to the minus 4. Now this is hydroxide. So when we take negative log of this concentration, 1 times 10 to the negative 4, it's going to give us a pOH of 4, and a pH then, they have to add up to 14 of 10. Pretty straightforward. Let's look at C. Now this is the other type of equation. We're going to have to do an antilog. Okay, so if you do antilog, and that's the 10 raised to the x power, and then the power is negative of the pH, in this case 5, that's going to give you 1 times 10 to the negative 5. Again, it's pretty straightforward because I'm using whole numbers. If I have not used whole numbers, then it wouldn't be so easy. That's pH. I mean, that's the hydrogen concentration. How would we find hydroxide? Well, hydroxide is going to be Kw, 1 times 10 to the minus 14, divided by hydronium, which is 1 times 10 to the minus 5. And what's the rule with exponents? You subtract them. And so you're going to get 1 times 10 to the minus 9. Right? Here we'll have a hydronium concentration of 1 times 10 to the minus 8. And hydroxide, 1 times 10 to the minus 6. Notice these two add up to 14. That brings us to our pH scale. When we take a look at our pH scale, we're going to see that typically it runs from 0 to 14. 7 is neutral, so I've picked green to be neutral. At that point, hydronium equals hydroxide. Kw is still going to be 1 times 10 to the minus 14. That's true all the way over. But when we have something that's acidic, we're going to have more hydronium than we have hydroxide. And basic is the opposite. Sometimes we call substances that are basic, we also call them alkaline. Let's take a look at another example. Here I have something with a pH of 8. I know it's basic. How can I find the hydronium concentration? Well, antilog of negative 8 is going to equal 1 times 10 raised to the negative 8 power. Pretty straightforward. What about down here? Well, down here, I can do it one of two ways. I can use Kw, which equals 1 times 10 to the minus 14. And then I can say, well, 1 times 10 to the minus 14 divided by 1 times 10 to the minus 8, and then that should equal 1 times 10 to the minus 6. Again, these are all going to have concentration values of molarity. We know their concentrations because they're in brackets. Another way to do it is to say, well, I had a pH of 8. What's the pOH going to be? Well, 14 minus 8 is 6. And what's the antilog of 6? 1 times 10 to the minus 6. You should get the same answer either way. Now, if this was a solution of calcium hydroxide, otherwise known as lime, how would we go about doing it? Well, I know that I have 1 times 10 to the negative 6 as my hydroxide. And I know that I have a 1 to 2 ratio. Why? Because look at my formula. I have 2 H's. So if I have 2 OH minus for every 1 calcium hydroxide, what's that going to give me? It's going to equal 0.5 times 10 to the minus 6. Typically we don't write things like that. So it would be 5 times 10 to the minus 7. Okay, that's how you're going to set these problems up. We're still using molar ratios. We're still using dissociations of acids and bases to look at how many hydrogen or hydroxide we have. But now we're just using this Kw and logs and antilogs. Let's take a look at one more problem. Here we have starting 0.03 molar HCl. HCl is monoprotic, so what's my ratio between HCl and hydrogen ion? Looks like the coefficients are 1 to 1. So I'm going to expect a 0.03 molar concentration. Okay. What's my best way for doing hydroxide? Well, I know that Kw equals hydrogen times hydroxide, and that equals 1 times 10 to the minus 14. So 1 times 10 to the minus 14 divided by 0.03. I took my kW value, I divided by hydrogen ion concentration. That's going to equal my hydroxide. And that's going to equal, well, when you type in 1 times 10 to the minus 14 divided by 0.03, you get 3.3 times 10 to the minus 13. Okay. What's the last one? Well, negative log of hydrogen concentration. That's going to equal negative log of 0.03. And when you do that, you're going to get negative log of 0.03 equals 1.5. Close enough. Now, when you take the log of something, that destroys the units. So pHs and pOhs don't have units. Hopefully you picked up how to do some of these calculations. If you go through the notes, you're going to see that there's slide after slide of more problems, and I'm going to put out some more videos later about how to do those. Be ready to do a quiz that's going to be something similar to something like this. All right. Have a great day.